Hi, Joel. Thank you for accepting my invite. It's great to have you here. And could you please explain and talk about your background, introduce yourself for our audience, please?
Sure. Okay. Thank you, Akshet, for this opportunity. I'm deeply honored. So, myself is Joel. I have recently done my undergrad in robotics automation from Saintgits College in Eastern Kottayam. And I'm also concurrently doing my degree in data science applications from IIT-Madras. I've always have been passionate into the world of robotics, and I've had the opportunity to go into it firsthand when I was in US. So at that time, I was in seventh grade, and the school, our school at that time, recently started a robotics club. So it was first club of its sorts within the district. So we were fortunate enough to try out several of these stuff which I work on nowadays in much more earlier years of my life. So all those full-fledged programmers, the controllers, and all the competition-based products, I was fortunate enough to try it out. And we also had the opportunity to go into a competition. It's known as VEX Robotics. It's pretty prominent in the North American region. So it's a competition where all schools across all the states and all across the districts they take part and fulfilling several tasks. So it could be either done manually autonomously. So from that experience onwards, I had always been much more fascinated into the world of robotics, and I was fortunate enough to pursue my degree within this field. And being a fresh graduate, I have been fortunate enough to go and try out various projects, competitions of sorts.
That's amazing. I did not know that you studied in the US. So can you tell me a bit more about what did you study and how did you find it? What are the differences when you moved back to India? What did you feel?
Okay, so I went to US. It was around the time when I just started fifth grade. Yeah, I went there as part of my father's occupation. So for we were there for 3 years. So it was mainly fifth grade, sixth and seventh. I did had some time adjusting there, but after that, I really did got used to the customs and the culture overall. So and during the sixth and seventh grade, I was very much fascinated on how they teach science or STEM subjects. So generally, they prioritize much on the practical aspects or the hands-on experience, whether it be the labs or theoretical classes as well. They will show us videos, animations, and during the computer times, they will actually make us do small tasks or projects to get a hands on how it is in real life. And coming back to India, I really did had a tough time adjusting back, mainly due to academics aspect, as the academic level or the way they teach in India is much more different than the US approach. So in India, it's much more rigorous, much more strict, whereas in US, it's much more laid back and practical. But over long and over time, I did get accustomed to this as well. I was able to do my undergrad here, fortunately, and I was able to do my dual degree as well. So I was able to adjust at the end of the day.
Okay, that's interesting to know. And thank you for sharing that. So dual degree, what stemmed that and what is it about? How did you decide you
So
want to do
dual
this?
degree as such, I initially did my I initially undertook my degree in B.Tech in robotics automation, and at the same time I recently came across the degree at IIT-Madras. So it was a hybrid degree where they give the classes online and they give the exams offline. So, but the rigor as the IIT tags itself is pretty much rigorous, is pretty much strict and strenuous. But I was fortunate enough to get to both the degrees, and it was pretty much helpful in a way, mainly because I was able to implement the learnings from my IIT degree into my practical projects in the robotics as well. So it could be mainly part of the data collection and data cleaning. So anything that revolves around data and its processing aspects, I was able to implement here in a practical aspect towards the robotics field.
Okay, that is super interesting. And how did you manage your time? Because a degree from an IIT is going to be time consuming and you have to
Yeah,
put in
yeah.
your efforts. How did you manage everything?
Honestly speaking, It was a difficult experience, to be honest, especially with the coursework from both the courses. And sometimes the exams do clash in between. So suppose I have my the end semester exams of my offline degree, and and if it ends on Friday, and the Sundays is when the IITs do keep my exams on. So I have to balance both the exams, the coursework, and sometimes I do have to attend the classes. So some classes are mandatory to attend offline. So it's known as open sessions, where we discuss with our doubts, where we discuss our doubts with our coursework and the mentors. So there have been times where I do burn the midnight oil to balance this out and get a good experience throughout the way.
Okay, that is interesting. Did it affect your performance for your, undergrad?
Honestly speaking, not that much. I was able to balance it out, thankfully. But there have been days where it was too much to handle, to be honest. But apart from those particular exceptions, I was able to handle it along the way.
Okay, got it. So would you recommend this kind of academic life to someone, or is it possible to learn all of this just not by pursuing a degree, but on your own? What do you think?
Honestly speaking, it depends upon their day-to-day life and how their routine is. Now, suppose if the routine is much more, disciplined or in much more orderly manner, I think they could be able to make some adjustments here and there and go along the way. But for those who want to do such programs and those who are currently doing such programs, I would suggest them to keep a day or two to balance it out. So suppose focus the first part of the week on our offline degree, and then the remaining part of the day is for your online degree. And in the end, just do a revision on either of them and do with your projects along the way.
Okay, that's good advice. Did it affect your social life?
Honestly speaking, yeah, it did affect my social life a bit, mainly because I had to reach home around 4 to 5, because if I do go past that, it would be difficult for me to handle the coursework that can be pending. So I
Okay,
have to take a decision personally to handle this. So at the end of the day, although it affected my social life a bit, I think in the long run it is beneficial for me personally and for my long term growth.
okay, okay, that makes sense. But in the end, it was your decision to let that part go and focus on what's important.
Yeah, absolutely. But when I talk about the effect of my social life, it's not as severe as I thought it would be. At the end of the day, I was able to mingle with my peers. I was able to make networks, make some fruitful connections along the way. It all depends upon how we manage it at the end of the day itself.
Okay, that is true. Correct. And what about your network at your IIT? Did you manage to make friends there, or was it all
Oh
just
yeah,
online?
absolutely, absolutely. So recently I took part being the core member of a robotics club at IIT. So it is where we will teach the technical aspects of robotics and tools. So it could be the mathematical side, the theoretical side, and the programming side. So we will be keeping weekly and sessions on how ROS2 is and how it works, and give them our juniors and peers on how someone who is not well accustomed to this field can shift to it and get a hands-on experience along the way.
Okay, okay. So what did you teach?
So I mainly focus on the programming aspects. So mainly ROS, simulation, and the modeling aspects. So suppose they have a project which they want to work with ROS, I will mainly discuss with them how they want. I will lay out their plan or their approach which they would like to do, and I will tinker it based on their requirements. And they will just create a model. Then they will revert back to me how it is. So whenever there are any hiccups along the way, I just guide them as a mentor to the best of my abilities, and I
Okay,
will share my learnings, which I was able to learn along my offline degree as well.
that is great, amazing. So you did have a kind of co-curricular side to this entire
Yeah,
journey.
yeah.
Okay. Did you do anything extracurricular or?
Extracurricular as such, I did do some swimming, although it's
Okay.
for my personal aspect. So I am pretty much interested in the swimming. So I was able to do it for the first 2 years of this program, but after that, I decided to just pause it along the way and focus full time on academics.
Okay. Okay. I generally don't spend a lot of time talking about academics, but since you
Uh-huh.
did a dual degree, I think many people would, benefit from knowing the
Yeah,
benefits and, the pros and cons, or how is it like to pursue a dual degree.
yeah, that's true.
So that's good. And how do you like plan to integrate your skills? How do you transfer your skills, data science skills, to your robotics?
So I do plan to work in a field where there's interest, where there's a combination between robotics and AI. So within the field of AI, we need the skills of how to manage, manipulate data, and bring meaningful information from the data. So I do hope that my degree from IIT and this and my learnings from the robotics side will help me tremendously along the way from a master's or whether it's my jobs which I plan to apply in the future. I think this particular styles of sets will help me accompany and be and a valuable part of the asset, whether it's in research or in company as well.
Okay. Okay, that is fair. One quick question in one line. Do you think that what you studied in your data science, you know, dual degree, can it be studied by not pursuing a data science degree and while pursuing your undergrad? Can it be done?
Uh, yeah, it is feasible, it is doable, uh, but there are few issues which I have faced personally while pursuing similar courses. So the main issue is that the lack of credible resources. Now, we might see resources which are, as they state, it may be credible, but along the way, we might see that it is not the way we want it to be. So suppose the end user wants it to be much more practical in that aspect, but the course might not be developed in such a way where they deliver it to the practical side or they just deliver it to the theoretical aspects. So sometimes the user has to take the blunt and go along the way and go through the process of finding
Mm.
discrete courses and discrete lessons to make it interactive and make it effective for themselves. But in case of the degree aspects, everything is all laid out, and everything's pretty much is laid out in such a manner that it balances both the theoretical aspects as well as the practical aspects. But in the long run, I don't think if we have the good skill sets, if we have the practical experience, I don't think if it would matter if you did this degree by itself or if you did the degree or if you did the same coursework from online directly itself. It's all depends upon your way of showing your skills and on your way of showing your expertise at the end of the day.
Okay, okay, that is correct. And just an idea for you, you can actually, since you've already done this, and not a lot of people I know have done this. So what you can do is create a segregated list of, credible resources that you said.
Yeah,
You said there is a gap that you don't find credible resources, you don't know the structure of what to study when and how and from where. So maybe you can create that from all those open source,
yeah,
places,
you're right.
because you
That's a
you
good
have
idea.
you definitely, got education from IITians, and they taught you
Mhm.
live or online, and that might
Yeah,
not be open source, but there should be something that's analogous to what they taught.
yeah,
So if you just put in like 1 day or 2 days of work, you'll be able to help a lot of people who want to do something like this, but they
hmm,
can't because of lack of credible resources or XYZ
yeah,
reasons. So this is just a
yeah.
thought.
No, you're absolutely right. That's actually a good idea. I actually plan to do it out in the future. Thank you.
Yeah, yeah, for sure. Okay. Now let's move on and talk about your projects. I think you have an excellent, amazing project to share. So why don't you
Oh
give a
yeah,
background of what it is and how you came up
sure.
with it, and then share if you
I'll
have
just
things to share.
share the screen right now.
Yeah.
Is my screen visible?
Yeah.
Okay, so this project is known as Navrover. So this project I worked on it as part of Build Space. So Build Space was a program where those who were admitted into it can work on an idea for 6 weeks and see how it works out from there. But I was fortunate enough to take part in the last program, and sadly, they have decided to shut down as a company. But overall, it was a very much learningful experience and an open experience for me. Personally, as I mainly focus on the theoretical side, I was able to learn on how we can market or project ourselves in such a way where where we can showcase our progress and our learnings throughout the world. So that is the main things which I learned from this project. So this project was actually based on a final year project. It's known as an autonomous exploration rover. So that rover focused on creating 2D and 3D maps of the surroundings and just perform normal autonomous navigation based on the raw stack. And the main highlighting features of the project were the rocker mechanism. So generally we see wheel robots on a fixed frame, right? But suppose if you want to make the rover or make the robot traverse across uneven surfaces, the map produced by such frames might not be clear or might not be much more accurate when compared to the data that is presented from other sources of wheel robots. So from when I did my research, I came across the mechanism, known as rocker mechanism. So this is a pretty old and pretty well tested mechanism. It's pretty much prominent in the space applications, mainly the Mars rovers which were deployed and the ISRO's rover as well. So they all used a variant of the rocker mechanism. They preferably use the rocker bogie mechanism, which consists of six wheels and a rocker and a bogie part. But I decided to just shorten it and just implement the rocker mechanism, mainly because I I was able to see that even when the rover does traverse these surfaces, the main frame of the robot was kept stable at all times. And this stability really helped along the way of making the map in a much more accurate and precise manner. And regarding the framework aspect, we decided to work on the ROS noetic part, as at that time it was pretty much the stable variant of ROS, and we decided to implement the built-in parameters known as GW and trajectory panel in the Navrover. And this project was actually a much more simplified and Dockerized version of a final year project. So there are some aspects of the project which I had decided to remove it, so that others who are delving into this field firsthand can get a hands-on experience along the way. But apart from the normal paths, it's able to do 3D mapping, 2D mapping, as well as the autonomous navigation and stuff. So this is the CAD model of how it looks. So everything is designed from scratch. Our main inspiration for this project was actually a Rover. So they are a company which designs such products for research and competition applications. They are a company based in Poland. So they were
Okay.
our main inspiration for this project. So we were able to implement this entire rocker bogie mechanism, the entire actuation part of the mechanism within the simulation itself. So as you can see here, although the rover traverses across the uneven surfaces, the box is being kept stable along all times. And this was a
Okay.
map which I made during the Build Space program. So it was a custom environment which I built, where
Okay.
it creates where I did a homage to the entire company as a whole, fine for their program. So it was a custom world which I built for them. And this map was later used to perform the autonomous navigation part. So that is what you will see here.
Okay.
Okay, so this is a so in the ROS one, it's known as ROS Nav Stack or Nav one, in unofficially they call it. But I decided to use the default built-in parameters and fine tune those parameters based on my robot's configuration. It did took some time on getting a sweet spot, but it was much learningful experience for me along the way, as I was able to implement my objectives at the end of the day itself. So this is when the robot is able to traverse autonomously based on the 2D map which was generated. And then this is one approach which I took for 3D mapping aspect. So as you can see here, the robot, as I control the robot manually, it gives a color coordinate of where the distance is and for each disk and for each color, it specifies the proximity of the distance.
Okay.
Now, suppose if it's purple, it's much more closer, but as you go along the way, it turns from the blue, then orange, then green, and at the utmost red. So this is the same aspect which you see generally at the back end of several 3D mapping algorithms. So one of the most famous ones, which I could think of implementing a similar approach to this, where they use the Octomap as well, is RTAB map, which I've also implemented as well. But the benefit of this map is that it just calculates the depth, 3D depth data, along with the distance data as well. Whereas in terms of the RTAB map approach, which you see here, it's much more extremely detailed as it collects the camera information, the point cloud information, as well as the normal occupancy grid, which they converted from this 3D data as well. So the implementation of RTAB map was a bit difficult to say the least. But after going through several approaches and several projects of how others are implemented it, I was able to get a pretty much good idea on how to implement it from scratch as well.
Okay.
And I was able to export this data and use it for other applications as well. So that's a one good big plus point of this RTAB approach, as we can either export the 3D data as itself, or we can export the images captured at each frame along the way and process that images to, let's say, suppose you want to create a digital model of an historic building. We can use the similar approach, but provided fine tune the parameters for the real life application, and we can do the same way for the real life world as well.
Okay. What sort of sensors are on this rover?
So regarding the sensor aspect, I implemented in the real life rover. I had implemented three sensors. The real life rover consists of the Hall effect encoders for the odometry,
Okay.
and the lidar for capturing the 2D depth data, and 3D information data was calculated from the uh, Kinect sensor, which you can
Okay.
see in this image here.
Okay. Was it a group project or an individual project?
Uh, this was actually the Navrover project was actually an individual project. I was fortunate enough to get some help from mentors along the way. But our final year project, this was a group project. We consist of four members. I mainly focused on the software aspects, and my other team members focused on the manipulator aspect and the documentation and the material procurement as well.
Okay. Okay.
So this is the initial model which I made for the Navrover. So as you can see here, it is much more. It is not as detailed when compared to the secondary version, which I will show you later on.
Mm-hmm.
The reason is that initially I did have some troubles converting the CAD model to URDF, as there is a certain way to convert this model to URDF. But the way I designed the CAD model, it was not possible at that time. So what I did was that it was a bit of an extremely trial and error process, but I decided to just implement the simple geometric shapes and just create a semi-accurate model of the Navrover itself. So that's the reason why you can see is using just simple geometric shapes along the way for the rocker bars, the motors, the wheels, the camera, the lidar, except for the Kinect sensor. As I ported this sensor part from the open source robotics framework.
Okay.
So they have an open source aspect of all the sensors.
Mm-hmm.
I put this part from their project into this as well.
Okay.
And in the second iteration, this is the second iteration, ROS 2 actually. I have completed the entire work in ROS 1. And in ROS 2, it is much more extremely detailed. It's actually a one-to-one model of the real life rover itself. But the main thing you won't see here is the differential bar. That's because the gazebo simulation has a issue, which I personally feel, in simulating a four-bar linkages mechanism. So that's one prominent issue which I think which I came across. I did came across several of work. I did came across trying several workarounds for it, but it was not really effective personally.
Okay.
So I just decided to implement it, the ROS2 controllers and the differential drive plugin from the Leo project, were as they have already open sourced the entire project for others to learn as well.
Are you sharing another screen because I can still see your initial design?
Oh, okay. I think I'm showing the initial design. Just a second. Sorry. It should be this one. This is the second model.
Yeah. Now it's visible.
Yeah.
So this
Okay.
is the one-to-one model you mentioned.
Yeah. Exactly. So this is the one-to-one model. So except for the differential bar, everything is as it is in real life.
Okay. And is this based on ROS 2 you mentioned?
Yeah. This is fully on ROS2 now.
Okay.
The entire ROS1 part of this project has been done, completed, and Dockerized as well.
Okay.
So if anyone is working in a ROS2 environment and if they want to work on this ROS in this project in ROS1, they can just download the image directly and run the bash scripts in the local system and everything. They can do it on the system itself rather than creating an entire ROS1 environment for them from scratch. So
Okay.
everything is in a containerized form. Others can try it out as well.
Got it. Got it. And now let's delve a bit deeper into how you did all of this. What did you study, and what resources did you use to study all of this?
Okay. For this mainly, I referred for the initial part. I referred to several of the online projects. So I did get some mentorship from Jeremy Peter. So initially, I was fortunate enough to get his guidance along the way as well. Apart from that, he shared me some documentations on how we can implement such projects from scratch. So
Okay.
initially, as part of the projects, I did some basic models initially. So a differential drive model. From the differential drive model, I then built upon the normal four-wheel skid steer mechanism model. Then from that, I decided to implement the rocket mechanism along the way. I think the
Got it.
best resources which I could say for this is mainly for ROS1 part particularly is the YouTube videos. There are plethora of YouTube videos to refer to, and almost all of them are pretty much well credible in nature. And the second part is the open source projects. So such as the Turtlebot project from in the ROS part,
Mm-hmm.
and the several skid steer based robots are there. So one from ClearPath Robotics. So they are pretty well
Yeah.
versed in this field. So there we can use their resources to see how ROS works, how we can implement navigation, how we can implement simulation, and how we can modify the parameters based on our use cases. Now, regarding the ROS2 part, the best resource which I can refer to for now is the documentation itself. So I particularly work with ROS2 Jazzy
Okay.
nowadays, as is the newest and the stablest version of ROS.
Mm-hmm.
And almost all the things from ROS 1 have been ported to ROS 2. So if you are planning to work with ROS or study ROS from scratch itself, I would highly recommend that you work with ROS 2 itself because by
Yeah.
next year it's going to be not being supported from
Mm.
henceforth. So you might have some difficulties. So along the way, if you do plan to study ROS 1 or ROS 2, and regarding if you want to port your projects from ROS 1 to ROS 2, that is still a bit of a gray area, mainly because there are only few projects which are being successfully ported to ROS 2. There might be few, but personally, I didn't came across few that are pretty much approachable for who are beginners or those who want a hands-on experience in this field as well.
Okay. Okay. Uh, and did you read any books, or how did you study the concepts like rocker mechanism? How did you know what to do?
Concepts. Okay, so the main references for the mechanical part. I referred to my professors in the mechanical department.
Okay.
So they taught me how it works. They taught me how it generally works and how we should do the calculations for the simple calculations for the part. But apart from that, I also referred to the papers of NASA and other open source projects and how they implemented and calculated the projects. But almost all of the projects are based on rocker bogie mechanism, I decided to modify the part and just tinker around with it to get
Okay.
my desired values. And the second resource which I mainly refer to is the YouTube videos. So suppose if you want to make the CAD model of such mechanisms, the best example is the videos where we make the six-wheel rocket mechanisms in the SolidWorks or Fusion 360. So we can refer to that and see how it works animation perspective. And from that we can make some parameters, change, make some calculation changes, and modify it to fit for our use cases.
Okay. Okay. That makes sense. Thank you for sharing that. And what was the timeline involved in all of these projects?
Okay, so regarding the final year project, which this was built on, that took a significant amount of time, mainly because we decided to work on such project from sixth semester onwards. So
Okay.
at that time, we did all the basic frame part. So all the mechanical part was already done and dusted there itself. At that time, we decided to just tackle the 3D mapping part. So no autonomous navigation, no navstat, nothing. We decided to build a simple React-based GUI, and we implemented a simple interface for the end user can control the robot and map the arena simultaneously as well.
Okay.
Then from that project, we decided to build and implement the 2D mapping part from the LiDAR, then implementing both the 2D and 3D navigation simultaneously and perform navigation as well.
Got it. Okay. So we talked about two projects. One is the hardware project that you have already built.
Uh-huh. Yeah,
So, and that was your final year project, I think.
yeah,
Okay. And it was a group project.
yeah. That was a group project.
Okay.
Now, talking about that mainly, the main highlights for that was how I implemented the localization part of it. So, initially, when we were implementing localization for it from wheel autometry, there was a significant amount of drift present in the data.
Okay.
So, to overcome that,
Mm-hmm.
we decided to fuse the data from the wheel autometry, the wheel encoders, the IMU, as well as the LiDAR. And we used that approach mainly because generally two is sufficient for most of the use cases. But since in our case it was traversing uneven areas and off-roading aspects of the environment, we decided to make it three. Mainly because by the fusion of these three data sources, we were able to get a pretty significantly accurate data of the odometry, which is critical for the robust localization and the navigation part.
Okay. What sort of sensor fusion technique did you use?
So I use so there's a package within ROS one itself and ROS two as well. It's known as robot localization package.
Okay.
So that package allows us to fuse multiple sensory informations, multiple odometry informations as. So the way I implement sensor fusion, it's not something which is fancy, but a bit of a few research and bit of references which I refer to. So generally, from what I've seen, uh, we generally employ two sensor sources for automated data. So it could either be visual odometry plus wheel odometry, or IME plus wheel odometry, or any two combinations of these three sources. It could be more, it could be additional GPS as well, but that's only in the case of outdoor projects. But
Okay.
in indoor cases which are GPS restricted, these three comes into the play. But in our case, since the rover is traversing across uneven surfaces and off-road environments, we decided to go ahead with the employing the entire three sources. Mainly because even after tuning the PID values of individual motors and fusing them, we automate the drift from both the sides of the robot was pretty significant. And so we decided to employ initially with IMU. We did that initially, but what we came across with that the issue was that sometimes with external magnetic interference, the entire robot starts to spin. As is, the entire visualization of the robot starts to spin.
Okay.
So we decided that is one thing which we cannot fix uh, apart from buying a pretty good grade sensors. So the another workaround which I came across known as was the lidar odometry. So the package specifically which I used for that was the RF2O lidar based odometry source, where it calculates the odometer of the robot based on the lidar readings. So if you want, we can say some much back more back the end workings of how the Hector Slam works. So it compares the current reading data, the previous reading data, and the future reading data which it might come across. And based on that data, it does the calculations and see where it is with respect to time. So by fusing these three sources and implementing the normal the EK filter, I was able to get a substantial localization data, and that helped significantly with the overall mapping and the navigation part of the of or the hardware aspect of the project. But regarding the simulation part, I decided to not include that, mainly because it could be a bit of a steep learning curve for others who wants to try it out, or for others who wants to learn with this project. So I decided to
Okay.
implement the default approach where we put very equal in the simulation.
Okay, I see. And you mentioned a lot of concepts: sensor fusion, extended Kalman filter, and control systems, PID controller.
Yeah,
Did you actually study all of these concepts and study them in depth, or did you use it?
few of the parts. So the main fundamentals of the control systems was part of my coursework
Mm-hmm.
in the offline degree. So I was able to implement few of the learnings practically. Apart from that, the filters which I talked about, the carbon filter and EKS
Mm-hmm.
specifically, I read the documentation from the package itself. It
Okay.
gives a pretty surface view of how EKF is
Yeah.
and how they have employed it.
Mm-hmm.
And based on that learnings, I referred to some few videos from MATLAB. They are pretty good for beginners who wants to learn how sensor fusion works, how it's employed in the real life applications. It's a pretty interactive videos to refer to. I refer to those as well. So from using those three sources, I then try it out practically. It took significant amount of time to make it work and get a good grasp of it, but I
Okay.
was able to make it work at the end of the day.
Okay. That is fascinating, and kudos to your efforts. What were the challenges that you faced, and how did you overcome them?
Oh, so the main challenges which I faced was the 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 URDF conversion. That was the main issue which we faced initially. Although I was able to come across with that. Personally speaking, I think that was the main issue. Mainly because all those resources which you generally see in the net are either for manipulators or fixed wheel robots. Only there are a handful of models which have employed such mechanisms within simulation. And after going and reaching out to the over there, they were. I was fortunate enough to give me a good idea of how it works, and they also told me that their entire stuff is open source as well. So I was able
Okay.
to go through the code, study it, how they implemented it, and I was able to recreate the same year as well. So that was the one main issue I faced. Second thing is the parts procurement. So I'm talking with respect to my final year project. The issue was that the electronics, mainly the computing boards and the sensor stacks, which we wanted to use at the end, were pretty expensive. So suppose the computing boards such as the Jetson Nano.
Yeah.
Initially, it was around 10 to 12K, but nowadays, since it's no longer being produced in production, those who have the board, they have marked up the price significantly, up
Yeah.
to approximately 18 to 20K.
Yeah.
But we were able to come across a vendor who was able to sell it in a manageable rate. And the second thing is the sensors. Mainly the sensors which we wanted to get are not shippable to India, or it takes months to arrive in India. So we had to find several workarounds to those restrictions as well. I think
Okay.
those are the main issues which we faced.
Okay. Got it. Got it. That is good to know that you solved them finally.
Yeah.
And How, what was the time commitment that you put in for this project?
Oh, took a significant amount of time to make this work at the end of the day, especially for the final year projects. There have been days where stayed up till 3 or 4 in the morning just to get the output I want. Because until then, I was not personally satisfied with the way the things were going.
Okay.
So until I don't get the output which I needed to showcase or to show the progress along the way,
Mm-hmm.
I sat up till 3 to 4 in the weekdays, and weekends I just burned the midnight toil and stayed up the entire day to make it work. But
Okay.
honestly speaking, I think it was worth it. I was able to learn significantly than if you were to, let's say, attend some few courses. Not that it's a bad approach, I won't say, but the time I was able to learn from these projects from itself were exponential compared to the general time which you would take when you were going through coursework.
Okay. I like this. Yeah. This is what I do, learning by doing,
Yeah,
and massive respect for your dual degree and investing so many hours and efforts into studying and learning this. And
it's thank you.
when did you decide that you want to do something like this?
So honestly speaking, regarding the project or
This the
the
project, yeah,
courses.
this is the project because this project is significantly long, so it takes some decision, and there's a journey involved.
Okay, so the main idea which I got from this project, it was when I was doing an internship. So this internship, I did it as part of the with my professor. So at that time, I was learning about Arduino in depth, like doing some projects along the way. So at that time, while I was controlling the robot, I got the idea: why don't we just create a robot that does the 3D mapping and the navigation part by itself?
Okay.
Albeit the 3D mapping is a manual process,
Mm-hmm.
and so from that day itself, I have been looking into ways of how others have implemented it and how others have taken their approach and fine-tuned it to make the to get the desired outputs.
Got it.
So I have read several research papers on this in both the offline on the off-road robotics part and as well as the indoor robotics part, as the approaches are pretty different in nature.
Mm-hmm.
So from that, I decided to work with the indoor robotics part, mainly because it's much more cost feasible, and also it's much more easier to share the resources along the way.
Okay.
And the next thing I did along the way was to take part in competitions. That's the first thing I did. So I took part in the competition was Yantra. I did took part in it 2 times. The first time it was when I worked with ROS hands down. I learned how it is. I studied the back end. I studied how it ticks and how we can implement it from scratch. And I did some very simple basic projects along the way to get a grasp of it. And I did learn significantly throughout the two Yantra competitions. So apart from that, I also asked my professors who do this, who knows about this stuff significantly. They're able to help me along the way as well.
Okay. Okay. That's good to know. Many people have suggested that participate in competitions and just talking to your teachers, having some peers who have similar
Yeah,
interests really helps a lot.
that's true.
So I'm glad
Yeah,
you did
that's
that.
true.
And lastly, now let's talk about how to get started, because all of this is like the finish line. You have
Yeah.
finished this project for now,
Hmm.
and you can call it like a complete project, even though no project is ever complete. But
Yeah.
it's something, it's a milestone. So
Yeah, it
this is the
is.
finish line now. How do someone start? How does someone start?
Uh, Personally speaking, now if suppose if they're doing their undergrad, I'm talking from the undergrad perspective initially, and then there would be the other aspects. So suppose they're doing undergrad in the core areas, let's say electronics, mechanical, CS, or any other part of the course subjects. Make sure to strengthen those fundamentals as much as possible. because those fundamentals will have significant impact into the field of robotics along the way. So, and the next thing I would say is that get a good grasp on programming. So whether it could be C++ or Python, either primarily focus on either one of that. So if you are new to programming in general, start with Python. There is a plethora of resources to refer to. The best, which that comes from the top of my head, is the CS50 course. It's
Yeah.
from Harvard.
Harvard. Yeah.
So through that, you would get a pretty good understanding of how programming is, how it is from a CS-based perspective, and based on our learnings, the next I would suggest is to study data structure algorithms because we need to have we need to get a way to, to process the data and make sure the data that is being processed and managed by these robots is as efficient as possible. Because at the end of the day, robots do have a significant limitation in terms of the computing power. When compared to albeit it is being developed at a rapid pace, there is still a certain threshold which we cannot cross
Yeah.
at those onboard robots. So by keeping that limitation in mind, we have to take we have to study and take few additional learnings or skills, which is DSA. C++ programming is one that I would suggest tremendously, especially for their fast computation speed and memories management.
Yeah.
Okay, I can get to use Python for the high level aspect of it. So maybe for AI, OpenC aspects or computation aspects, those parts can be implemented with with Python
Hmm.
or with C++ as well. But that is an extremely steep learning curve. Provided if we have a good experience along the way, you can do that. But you can develop, but you can separate these two parts. One for the low level part of the robots for C++ or C, the higher part of robots learning, we can focus on Python. Now, if you aren't from this field, now if you aren't from the engineering background, I would suggest that you watch a few videos, theoretical videos of robotics. Now, it might be a bit steep, extremely steep learning curve at first, so as it includes linear algebra, probability, few aspects of probability regarding the navigation part. That is where it comes into, and the several other high-level mathematics that comes into play here.
Okay.
So, if you aren't from a core field, I suggest that you strengthen your max first, or which is necessary for this field, and then you refer to the basic courses which are there in YouTube. So it tells you about the transformation matrices, the how the calculations for a wheeled robot is apart from a manipulator robot, and how is it for the how does a robot map, or how does a robot understand the surroundings, or how does a robot localize or navigate by itself. So all those theoretical aspects, after covering those, it might take several months along the way, and that's absolutely fine because robotics it's a field itself it will take years to master.
Yeah.
So don't rush into it. Take your time, go through it, and if possible, do some small projects along the way. It could be as simple as an Arduino-based robot, because that itself is a significant learning progress. So from that, you do your projects along the way, and then you work on ROS 2, and then after you get a good grasp of the fundamentals of robotics, then you work on a pretty good substantial projects. Yeah, I think there are pretty good resources which you can recreate. I suggest you to recreate those projects rather than just studying and utilize those open source projects directly. As the process of recreating will help us tremendously and get a much more clarity along the way. So that is
Yeah.
what I mainly suggest for both the aspects.
That is excellent advice because I can see all the similarities between what I suggest to people. I always suggest the CS50 course and data structures and algorithms. Everything is related to efficiency, and you need to
Yeah.
be a good programmer, C++ and Python. So I'm glad you shared all of your experiences. So what are you planning next? What's next for you?
I am planning to do my master's within few years. It's within the field of AI and robotics mainly. and I do plan to work on the upcoming fields. So I plan to look into ways how we can implement large language models or VLMs, and how can that be integrated with robots in general. As
Okay.
that as from personally from what I've seen, using of such AI-based techniques or AI-based frameworks can help significantly with the human-robot collaboration along the way. And the next thing which I would like to work on is Gaussian splat. So that's a pretty new area which I myself have not delved deeply into, but it is mainly used to create 3D environments just from images itself. So I think we can implement that in the mapping part of the in mapping aspect of the robots.
Okay. Got it. Good to know that, and I do wish you all the best for your journey.
Thank you,
And
thank you.
thank you for your time once again.
No, thank
And
you
it was
so much for
great
the
talking to you. I
opportunity.
think this was the longest
Oh
episode
wow,
I've recorded so far. So, yeah, thanks for your time, and it was great learning from you. And I'm sure people will benefit from it. So,
sure.
wish you the best and see you.
Thank you so much.
Thanks.
See you. Bye bye.
Bye.